Hi, good day. This is the second lecture on scalar isobaric analysis continued for West and North Africa. And this is the map from which it is cropped for North and West Africa, so that the map can be enhanced for us to see values of the stations properly. And this is the map that has been cropped for West Africa and North Africa, West and North Africa, cropped from the main map. Now looking at this is already an analyzed map of West and North Africa. That is isobaric analysis of pressure. Before the analysis began, we had to identify or to indicate the ITD, that is the intertropical discontinuity over West Africa, and to discover or to put the ITD, intertropical discontinuity. We use dew point temperature of 15 degrees Celsius, as well as wind direction. Wind direction is southwest, south of the ITD, and northeast, north of the ITD. And that's what we can see here. This is the ITD now located with dew point of 15. Before we can locate that, we look at the stations. North of the ITD, let's see, we have a station here. And that station circle is already blurred by the analysis, however. So if you look at the top right, that is the north of the station circle, north west, you see a value of 35. And then south of it, you see a value of 3. This 3 is the dew point temperature, while 35 is the temperature, showing us that the ITD is south of this dew point temperature because it has a value of 15 degrees Celsius. Then let's look at the station at the coast, as this one. We see that northwest of it we have 35. It's 35, while here is 25. South of it is 25. This is the temperature of the station, and 25 is the dew point temperature. So this is indicating that the ITD is north of this station. So we now interpolate between this station that has 3 degrees Celsius for dew point, and this one that has 25. So it occurs in between by interpolation, and of course it's identified as ITD with the double dash lines. The same thing is done looking at the station to the left. And if you look to the left, you see around here a station with value. This one is value, the temperature is 21, while the dew point is 7 here. While the one at southern part of it, the temperature is 21 and also 5 as the dew point temperature. So, and of course there's no other station around here, so we use this same station to interpolate to get the position of the ITD. So the ITD continues like that and ends here and label ITD. Then after this, we now continue with the isobaric analysis. That's the analysis of pressure. Now the analysis of pressure, we begin again with 1000. We look at 1000. Therefore, 1000 we can increase or decrease on the basis of the station values of pressure. So with this 1000, we take it here is 988, and of course, looking up, looking north, the station, the values are increasing. So we take this 1000 through here, This is 982, so 1000 will exist between that and this already analyzed 1008. So based on the cropping, we stop here, then continue from here. This is 1000 again, passes through here, down, and of course here is less than 1000, and here is more than 1000. So 1000 now ends here. All right. There's another 1000 to be drawn south of the ITD, because the temperature, the value here, pressure value here is 1011.011. So we draw the 1000 hectopascal, and that's it. This. All right. Then we start reducing. We now go to 992. 992 will exist between this 1000 and this one is 985. So 992 can exist there. So we draw that 992. At the ITD is starts and continues north of it and over here. And then this is 992 again here, because this is 982 and this is 1000. So 992 exists between 982 on the station, and this already analyzed 1000 isoplate, 1000 hectopascal isoplate. So we take it down, down south, 992 level. Then here we have to wriggle up and down like that, based on the values of the station, and then down to this place. Each time you are taking the line, the isoplate, you watch the station to ensure that the 992 value can pass between two stations. All right. Then 992 continues from here down, hitting the ITD, then south of the ITD continues to this point. Then we go to 984. 984 is this one. Exists between the line already analyzed of 992 and looking at this station, you have 956. So 984 must exist between 956 hectopascal and 992 hectopascal. So we take this between here and then through there, then down south 984, and then this way, and here we have 985. So 985 is almost the same, just pass it through there. And then there are other intermediate lines. They are not intermediate as such, some other lines of 88, but it will be very, very compact. So I went straight to 960. Analyze 960, this is 956, should be in. So 960 will be to the east of it. And then round like that. And then this way, this is 958. 960 should be west of it, and then down. Label 960. Then this 1000 can 1008 can also be drawn, because this station is 1011. So 1008 can exist between 1011 and already analyzed 1000. Then over here the same thing. We have 1008 going through there and there. All the time watch, look at the stations to ensure that the values, the isoplate you are drawing must exist between two values, must be accommodated between these two values. Now for then the next is 1016, which is this at the station, and that. So we now have to this left western side a high. All right, so that's all about this. The same is done over here. 1000, 1012 and a high. So until the analysis is completed. And so that is how this one is analyzed, the West Africa and West and North Africa. This lecture will be brought to an end, but before then, the next lecture we now handle upper level map at upper level. That is, we take 925 hectopascal level. This time around we'll be analyzing contours.